So the goal of this particular program is to try to solve a problem, solve this task that we have, and then we'll learn all of the features in Java that we need to know in order to do this problem. Okay, so let me just summarize again what we're going to do. I want to be able to eventually, this is the ultimate thing, ask the user how many times they want to flip the coin. So they can enter 10, they can enter 10 million, they can do whatever. Okay. So then the computer is supposed to flip the coin. Okay. But our problem is we have to simulate that. So yesterday we said that we can use the random method from the math class in order to simulate that flip. The random class generates a number between 0 and 1, and we can use that. I think we got that taken care of. The next thing I want to be able to do is I want to count the number of heads and the number of tails. Okay, so we have a tally of each of those. And then I want to compute the percent of each. That's heads or tails. And if we flip it a lot of times, that should come out to be about 50-50. Okay, then we know our simulation is good. All right, this is the ultimate goal, and we're like partway into it right now. So let's take a look at, I think we can finish this one today. And so let's get going. All right, everybody in? So this is the program that we had yesterday, and I always like to just run a program that I've got here to see where we were at. And so I see that we have a problem here, okay, and the problem is that our program is running infinitely, and with this the way that it was. Can anybody remember or look at it right now, what's the problem that's going on? What's that? The counter. So let's go back to the counter. The counter was going to see how many times we were going to flip. So we created this variable called counter, and set it equal to 0. It's an integer. And then we said, while the counter is less than 5, do this. So this is where we had actually flipped it up here, and it's determining what that flip was. And if it's greater than 0.5, greater or equal to 0.5, we say heads, tails. And then it just goes back up and checks to see if the counter is less than 5. That's a problem, because the counter will always be 0 unless we add 1 to it inside of this loop. The other problem that I see is that, see where we flip the coin? We're flipping the coin only one time. It's not inside the loop. So that's also a problem. So where we put the while makes a difference, and we have to make sure that we increment that counter. So let's go fix this. So the first thing I think I want to do is I want to put the flip inside. So I'm going to cut this where we actually flip. So Control X this. And I'm going to paste it right here. So now this is where we actually do the flip. And go ahead and save it let's go run it again. Now, if you're in the middle of this, remember that this little red square is how you terminate the program. So go ahead and terminate this one, run it again, and you should see a subtle difference. Okay. What's the difference? We're now flipping this an infinite number of times. Okay, we're picking a random number between 0 and 1, printing it, deciding whether or not it's a head or a tail, and then printing head or tail. So this result that we see here is actually doing what we want to do. It's just never going to stop. Okay, so terminate this one. And let's go fix this. So let me ask you, where would be a good place to add 1 to the counter? At the end of the while loop. So inside the while loop, see how I clicked on the curly brace? This entire thing is called a block of code. Back in Alice, it was actually one of those big rectangles where you drag stuff. So inside of this loop, but outside of the if statement, I think right after we do the flip and decide what it is, this is where we should add 1 to the counter. Okay, people, I wish there was a good word that meant add 1 to a variable. Anybody remember what we called it in Alice? How to add 1 to the variable? Increment. Remember that? Okay, so right here, we're going to say increment the counter. And I'm going to show you how to increment it. We say counter equals counter plus 1. And if you go run the program and you count how many times it flipped, 1, 2, 3, 4, 5, it flipped exactly 5 times. Now, this is super. I'm going to explain how this incrementing is actually working, because this is super important that you understand this. This line right here, counter equals counter plus 1, adds 1 to the counter. Now, how does it do it? It's important that you know how. This is called an assignment statement. Anytime you have an equal sign, what it's doing is it's assigning the right side of this, it's assigning it to the left side. So this is what it does. It starts to figure out, all right, when it hits this instruction, it goes right to the right side. And it finds counter. And it says, okay, counter, what do you have in you? And so we look inside. So here I am. I'm being the computer here. This is my counter. What's the value inside counter? Right now, at the beginning of the program. 0. Okay, so I peek inside here. There's a 0 inside there. I can see it. Okay, that's counter. And so it says, what do you do to the counter? It says you add 1 to the counter. Okay? That gives us an answer of 1, and it stores the answer in the counter. So counter is now 1. So now, after that instruction, if I look inside here, I can see there's a 1 in here for counter. Okay? The second time through, it says counter equals counter plus 1. So counter now is 1. We add 1 to it, it becomes 2, and the answer gets stored back in the counter, so it becomes 2. Yes?
Why can't you use plus plus?
Because that's kind of a black box, and we will use that. But if you don't know how this works, then counter plus plus doesn't make any sense. I try my best to try to explain things so that everybody understands how it works, not just like, hey, just do this because it works.
Another question.
Yes?
If you use, I just did counter plus plus and ran an infinite loop. Why would that
Depends on where you put it. Did you put it inside the while loop?
Yes.
Click on your curly brace. Is it inside?
Yeah, it is.
Okay. Let me take a quick peek at this. And everybody else, go test this out. Put in different numbers for 5 and see if it does what it's supposed to do.
I just don't know the syntax. Swivl.
Yeah, see, you don't know the syntax because you're saying counter equals counter plus plus, which doesn't make sense.
Okay.
Why is my
So do what I'm doing.
black?
Oh, just hit the insert key. You're on overwrite mode. Okay. Anybody put in a ridiculously high number? Okay. How fast does it take to do it 1,000 times? It's already done. Okay. So how about a million times? How fast does it take to do a million? I see that it's taking a long time to do a million. The reality is the computer can do this in less than a second, but it's the fact that we're printing it, that's the thing that slows it down. So I'm going to show you what I like to do is I like to put a statement here to make sure that I know when something's done. So look at this. After the while loop, let's put a comment in here where we just say done. That way I know that we are done. So when I run this, it'll do its thing, and then when it's all done, it'll say done. But I want to do this because I want to demo how fast this bugger can actually be. Because we're going to see now it's done. Okay. So watch this. This is crazy. Comment out temporarily all the print lines. And let's do this a million times. I mean, I think it's less than 1/10 of a second. It can flip a coin a million times in about 1/10 of a second. Okay? It's the printing that slows it down. Isn't that cool? Okay. That demos how lightning fast the computations are. It can do that many computations that fast. As long as it doesn't have to print, it's like amazingly fast. Okay. All right, moving on. Let's see what we got here. I want to look at what I got here. Ask the user how many times. So we have to do that yet. Plus we have to count the number of heads or tails. Then we have to compute each of these. And we should probably display all those results as well. All right, what I want to do is before I do the flipping, before the asking, I want to just put this back into 5. I'm going to add the how many times do you want to run later. What I want to do right now is count how many times there's a head and how many times there's a tail. Okay, so, and I think I'm going to put these print lines back in here only because we want to validate whether or not it's doing this correctly. Okay, need your help. How do we keep track of how many times there was a head that was flipped and how many times there was a tail that was flipped? How can we possibly do this? Can make a variable for each. Okay? So maybe we'll call one total heads, the other one total tails. And what data type do you think these should be? They should be integers. They're not going to be doubles because they're actual integer values. Okay, that's all good. Where in the program should we declare those variables? Before the while is correct. Okay, so right here is a good spot. So let's say int total heads, and should we give it an initial value? 0 is good because it should start off at 0. And then total tails should be a 0 as well. Okay. So what we now have is we have 3 shoeboxes. One is for the counter, one is for the total heads, and one is for the total tails. There's like 3 of them now. And they all have a value of 0 when the program starts. Okay, now what? Good. So we're going to increment total heads whenever there is a head that was flipped. So where in the program, look at my code, what line of code would be a good place to put that? Where we increment the total heads. Between what? Between 29 and 30, right here. Okay? So right here, we're going to say total heads equals total heads plus 1. We're incrementing the number of heads that were flipped whenever a head was flipped. We're going to do the same thing now for tails. Whenever a tail was flipped, let's add 1 to the total tails. So total tails equals total tails plus 1. Okay. Now go ahead and run it. And I'm just using 5 here. So I spy 1, 2, 3, 4 tails and 1 head. How come I can't see how many heads or tails I've got? Do you think the values got incremented? Yes, but we just didn't display it. So when we're done with the loop, let's go ahead and print. So let's say after it's done now, we can say system.out print line. Let's say something like this. Heads equals, and then we can say total heads. This is using a little bit of what we did in CS1. And then tails equals total tails. Run this a couple of times. Double check to see that if it's doing it correctly. Okay. Just because it does it once may not be right, so double check it. And then I'm going to have a little fun here. I want to make a whole bunch of flips, which means if after I know that this works okay, and this is looking like it's working correct. So now I'm going to flip it a whole bunch of times. So how about 5,000 times? Well, let's go 10,000 times. I suppose I can keep those in there. So that's coming out to be pretty close to half and half, right? Let's do it 1,000,000. And again, if you were to take out the print lines, once you have faith that it's actually working, this produces a result in a split second. So mine turned out to be about 500,000 for each. Okay, which is pretty good. This means that our randomness of flipping the coin is not slanted in any way. It looks like it's pretty good. Yeah. Oh, press the insert key right here. You're on overwrite mode. Okay. So that's looking pretty good. We count the number of heads, so I can say check mark, we're flipping the coin. Let's compute now the percentage of each and put that in there. So how am I going to do that? How do you calculate the percent of heads or the percent of tails? Like for this example, there were 500,175 heads. How do I calculate the percent that heads was flipped? Let me change this to only 5 and run it. If I flip it 5 times, what percent is 4 out of the 5 times? What is it? 80%. Okay. How did you get that? What fraction?
The amount that you flip it over heads or tails, whatever you're trying to find.
Whichever. So 4 divided by 5, okay, is 80%. Tails is 20%. It's 1 divided by 5. Okay. So how can I use the numbers that are in my program to have the computer automatically calculate the percent? Heads over what? Over the counter. Do you agree that the counter is the total number of flips? Okay. So that means that we can do this. And I'm going to show you, I actually am going to prefer that we create a variable, okay, that represents the percent. What kind of variable should this one be? Data type. Is it an integer? It's going to be a double. Make it a double. So it's double. I'll call it heads percent equals heads percent and what math do we do? Yeah. What are we going to divide? You tell me. Total heads divided by by counter. And let's do the same thing for the other one. It's tails percent equals total tails divided by counter. And then let's display what those are. And I think I want to put it something like this. So we calculated the percentage of each one. We're storing that in a double. And then we're printing the heads percent and the tails percent. And go ahead and run it. And let's analyze the results. Okay, does everything look good? No. Okay. Problem here is that the heads percent and the tails percent are both 0. What's with that? What's with that? It's supposed to say, in this on mine, it's 4 and 1, so it should say 80% and 20%. But it says 0% for both. I need to know why. Multiply by 100? Is that going to fix it? When we went through the loop, the counter went down? Okay, good question. Let me just, I'm going to put in a line here that says total flips, because I want to see what that variable is. So total flips equals counter. So counter does have the correct value. Counter is 5. Total number of flips was 5. So at this moment, that shoebox is still correct. And total heads and total tails are the correct values. I need to know what the heck is going on here and why we got 0%. Okay, he's on the right track here. Here's the secret. This is really super important. Remember when we said Java does integer division when it's working with integers? Which means as soon as it got to this spot right here, total heads divided by counter, on mine, this was 1 divided by 4. Okay? How many times does 4 go into 1? 0 times. Okay? And it doesn't look at the remainder. How many times does oh, not 4, that'd be 5. How many times does 5 go into 4? 0 times. That's why the answer is 0 for each of those. Whenever, this is so important, whenever you divide an integer by an integer, the answer is an integer with no remainder. Okay, that's why the answer is 0. But it's funny, it's printing 0.0 because we're storing that integer 0 in a double variable, which is why it's printing 0.0. This is the moment where we have to do that cast. We have to tell one of the variables that are an integer to just temporarily pretend that you are a double. In this case, what we're doing is we're telling total heads and total tails, hey, you guys, I want you to make sure that you are we're going to get the correct answer here. So just temporarily pretend that you are a double, not an integer. That's what the parentheses with the double inside. It does it to the variable that's right immediately after it. Okay? It tells this variable to pretend that it's this data type. So it's pretending to be a double. So now look at the results. Heads and tails, 0.2 and 0.8. That's just good what we want. Well, I don't know. Most people, when they look at this, they don't know how to write that as a percent, right? They see 0.2 or 0.8. They don't know if that's 2% or if that's 20%. So let's give it to them straight. What is 0.2 as a percent? It's 20%. How can I make this display 20% rather than 0.2? Multiply it by 100 is correct. So where should I do that? Where should I multiply it by 100? We should do it, now this is really important, we should do it here rather than on the top line, because this is where we don't want to change the actual percent. The percent is still 0.2. And so this way it'll show, in my case here, 40 and 60 rather than the actual percent changing. It's like just how we're displaying it, we're not changing the actual value. Now, I think it'd be more pretty if we put a little percent symbol on the end. So we'll pretty this up. And run that. I think that's looking good. Yeah, it's a round off error. I'm going to run mine a couple times. We'll see how we get there. And I'm going to do another little pretty up thing. I'm just going to put a little line in here so it separates the results from what I have. So it's doing all this. Total flips is 5, 2 heads, 3 tails. That's 40% and 60%. All right, I'm going to run this a million times and see what happens. Okay, what do we got here? This is about 50.06 and about 49.94. That seems pretty legit. Anybody get any weird numbers coming up here? Like 0.00000001. If you get something like that, it's a round-off error. It's made by the computer when it has to translate between binary and decimal. So it's not a big deal for us. Okay, is everybody's working? Calculates the percent. Now, I don't know about you, but this is kind of ugly still. I'd like it to be more pretty. Maybe have maybe just display like one decimal place or maybe 2 decimal places. That way it's not off-centered here in any way. So what I want to do is maybe round. I want to be able to round this and then just have it display like maybe 1 or 2 or 2 decimal places. Let's do 3 decimal places. All right, how do we do that? How can we force it to only do, say, like 3 decimal places? Just tell it, hey, you know what? Just don't look at the rest of this. That's what you do, actually. You just tell it, and then it knows what to do. Yeah, watch this. Your kids will be going to programming class, and then everything will be so sophisticated that they just tell the computer what to do, and then it just writes the code for it. And you'll say, in my day... All right, I'm going to show you something. I'm going to show you something right here. Everybody put your cursor right at where we're working with that percent. And I want you to type in math dot round. You'll see round in there. And what I want to do is I want to put heads, I want to take out the parentheses so I'm rounding this value right here. So do the same thing for both. Look at my parentheses. That's really important that you see. Oh, shoot. I'm going to flip mine back to 5 times. So the math class has a method called round. And what round can do is it chops off the decimal place by rounding it also up. Okay? So this chopped off the decimal place and it moved it over. So this actually looks really super good. Okay, 40 and 60%, it looks really pretty. But my problem is I want like 3 decimal places here. Yeah, we can tell it to do only a certain decimal places by doing this particular trick. So I'm going to show you a trick right now where right here, what I'm going to say is we're going to round it to 3 decimal places. So I'm going to multiply this number by 1,000. And this is not going to make sense until we're completely done. All right, notice where it is. I'm multiplying it by 1,000 so that what I'm really doing is I'm displaying five numbers right here. Okay? And it goes ahead and rounds it right at that moment. And now, this is the secret right here. We're going to divide this answer by 1,000.0. And this is a little mathematical algorithm. That will display that will round it to 3 decimal places. Okay, round it to 3 decimal places. Because there's 3 zeros here and there's 3 zeros here, the real short version. But what's going on is we're multiplying the percent by 1,000, rounding it, and then dividing it by 1,000. Now, you can't tell with just 5 flips, but if you picked something like, 17 flips, where you know that it's not going to divide out nicely, you can see it's displaying 3 decimal places. So total flips is 17, 10 heads, 7 tails, 58% and 41%. Make sense? Okay, what if just so we understand what's going on here, this is a little trick that I'm doing. What if I wanted to round it to 4 decimal places? What would I do? You would multiply here by 10,000 and then divide by 10,000. So if I want 4 decimal places, this is a little mathematical algorithm that will get you 4 decimal places of accuracy, and it will round it to that 4th decimal place. So it's the number of zeros here is equal to the number of decimal places that you're going to have here. And this is a cool little system, a little mathematical algorithm that gets you there. Okay, I say we have pretty much everything we know except for the last part. Ask the user how many times they want to flip. So let's finish this thing off. So where should that go? Where should we ask the user how many times to flip? Now, we're going to store that answer in counter, or pardon me, we're going to store that answer right here, okay? So it doesn't matter if we go before or after. I think what I'm going to do is I'm going to put it right here. I'm going to say, let's prompt the user, how many flips do you want? And then let's create the variable. It's going to be an integer. And I'll say num flips equals, we don't have a scanner. So we got to put it in the scanner. So call it whatever you want. And remember the shortcut is you can just click on the red X here and then click on the import scanner. It'll do the import automatically for you. And then you can finish it off. And then the last part is, if we put num flips right where I have the 17, it'll flip it exactly the number of times that I want to. So I want to flip it, I want to flip it 10 times. And there we go. I'm going to run it again. Flip it 19 times. And everything's looking good. So we added the scanner. We asked how many flips do they want, and we put num flips in place of where we used to manually put the number. And everything's good. Mission accomplished. So we know about the while loop, the if. This one included a lot of stuff. The while loop, the if statement, incrementing, random, rounding, all that good stuff. Yes? Oh, great. We'll handle that when we come back. This is dependent on user smartness. Okay? If they enter a number like -1, okay, what'll actually happen is the program won't run. It'll just try to do the computation, and it'll end up bombing when it does the division.
I did 666 and it ended up doing it perfectly right there.
Oh my God, that's awesome.
Buy a lottery ticket. I know.
Lottery ticket time. All right, have a great weekend.